So the next question, Spencer stands 25, this should be meters in from the base of a tree. The angle of elevation of the top of the tree is 17 degrees. So here we have Spencer, this is his location, and this is the base of the tree, G, and he's 25 meters away from the base of the tree. And this tree has a height TG, and we're asked to calculate the height of the tree, TG. Could be GT, same way, looking at this height here. The answer must be corrected to 3 significant figures. When we look at this, we're seeing the angle of elevation being 17 degrees in respect to the top of the tree. And the elevation is always from the angle of elevation from the ground level, because we're elevating upwards to the top of the tree in this case. So we have a right angle triangle here. As we can see, we have a horizontal line and a vertical line. Horizontal line meets a vertical line at 90 degrees. Now, we want to figure out what concept we can use to find this height here, or this side of this triangle. Well, we have a right angle triangle and we have an acute angle, so we can think about trig ratios. This acute angle tells us that this side opposite is the opposite side. This side TG is opposite the acute angle of 17 degrees. This side that has the acute angle and the right angle is the adjacent side, and we're given the adjacent side. So we will use this in our calculation. So we're given the adjacent side and we want to find the opposite side. And so we'll think about which ratio. That's correct, the tangent ratio. Remember, you have SO, GA, TOA. Well, I'm having them in the wrong order, but SO, GA, TOA. Now we'll use TOA because this is the tan ratio. So tan theta is equal to the opposite side, or the length of the opposite side over the length of the adjacent side. Now this is actually on your formula sheet in your exam. You're given this formula in your exam, in fact, for all the trig ratios, and so you just need to know how to use them. Now the theta here, it represents the acute angle. The acute angle we're given is 17 degrees, so it's going to be tan 17 degrees is equal to the length of the opposite side, in this case is unknown as TG, and the adjacent side is known, and that's 25 meters. So if you want to find, if what you want to find is in the numerator, you're going to multiply these two guys here. So TG is equal, simply multiply tan 17 degrees by 25. I like to put the number in front. That's going to be 25 times tan, and this will be equal to, ensure my calculator is in degree mode as well, and my answer there is 7.64326, etc. Our answer should be corrected to 3 significant figures. The first non-zero digit in the number is 7, so I start counting from 7, so that's the second significant figure being 6, the third significant figure being the 4. So I'll cut this off, and we always want to check the very first digit we're cutting off. If it's 5 or more, we'll add 1 to this, the required place. But because it's less than 5, we'll maintain it as just 4. So our answer is going to be TG is equal to, and this is corrected to 3 significant figures.